Hello and welcome to this talk, Impact of Global Change on Spatial Dynamics in Venezuela, Los Andes ecoregion case, into the Sustained Long-Term Ecological Research in Venezuela, Opportunities and Challenges, a symposium, which is a part of the virtual meeting of the Association for Tropical Biology and Conservation. I am Eulogio Chacón Moreno from University of Lleida Department of Crop and Forestry Science and also the Institute of Environmental and Ecological Science, ICAE, Venezuela. We're talking about today about four things, but mainly try to explain what are we doing during the last 20 years in research in landscape ecology, with an example of Andes and monitoring the tree line and special paramo forest moving upwards. We know that global change, the air have been changed during the 4,600 million of years with extinction and life evolution. However, the humanity and the man and the woman also accelerate the process of change, and now we have a global change, but is a lot of driver agents that cause change in the global and regional space. And we will focus especially today in two of these in relation to the Andes, which is climate warming and alteration of precipitation and land transformation, and how we can identify some indicator of change, and then how can make a monitoring process, especially for the last part of this meeting. Then the question is how this agent of change impact the spatial dynamic of the tree line in Venezuela, in Los Andes. And what is the tree line? Is this area between forest and paramo, specifically where the ecotone of paramo forest occur around 3,000 meters. And the study that we present in this speech is based on landscape ecology approach using multi-temporal studies of the last 5 decades to determine the transformation of the tree lines and movement of a tree line in the Cordillera de Mérida, Venezuela. Cordillera de Mérida, we have 3 areas to study. One is the Capaz area. The second is the Sierra Nevada National Park, a small area. And the third area is the Alto Chama Basin, High Alto Chama Basin, where we carry out different studies. In the Capaz, focus on transitional ecosystem map and vertical ecosystem rate displacement, and on Sierra Nevada National Park, the study of vegetation map with detail on the structure of the vegetation and metrics of change. In Alto Chama, we compare ecosystem map to ecosystem of potential map. In the case of Capaz study, we obtained 5 maps corresponding with 4 periods of a study, where identifying 4 special or main ecosystem: paramo forest, which is the ecotone, crops, forest, and paramo. And we calculate and estimate a lot of transformation rates of change from different states, and create a model of states and transitions. Especially we can see how paramo is going on or is transforming in a forest through paramo forest, and we see that the main transformation and the black arrows indicates the main transformation during these 57 years, with an area of 12 hectares per year. However, we concentrate in how it's changing in the vertical dimension and also estimate how can move upwards. And we understand and we found different estimation, but if we consider vertical displacement that derived only from Páramo ecosystems, around 22 meters per decade per every 100 meters of horizontal distance. At the end, when we make average, the vertical displacement is around 22 meters per decade per every 100 meters of horizontal distance. And what we did in Sierra Nevada National Park was compare only to date, 1952 and 1998, comparing the structure of vegetation, and we obtain a table with for the major ecosystem with this Páramo forest and mountain forest. We find vegetation types. And in Alto Chama study cast, we made a map of ecosystem from 2018, and from this map we calculate a potential map and study how it's changed from nothing or from no use to use, and found that most of the Páramo forest disappear for use of agriculture. Now, in relation specific with Páramo forest and climate change, we see in climate that more or less, considering in different dates, the weather is changing in around, for Mérida airport is higher, is 0.18 degrees per decade, and for the Venezuela is around 0.06 degrees per decade. Considering this aspect and how it's moving, at the end we found that if we consider only the whole forest ecosystem vertical displacement, that is 14 meters per decade, the rate of forest migration is lower than the potential warming, and this rate is realistic because it includes the successional process of forest ecosystem. This means that the forest is going slowly relation to what the potential change correspond with the climate change. And this is an image of how it could be changed and moving, and this is the structure of how can upwards the forest to climb to the Páramo system. Well, finally, to understand this global, to create a frame, we have to understand how is the relation between all the factors, all the agents and the interrelation between possible strategies for understand very well what is happening. Then, using this frame, the real question is now how to implement a monitoring program in order to create strategies to adaptation, biodiversity conservation, and we think that it's important considering different criteria like different levels, indicator, real budget, but this is very important now in the condition of our country, national and regional support, decentralization, and also be more deep in research, capacity building and managing. And this is what I thinking that we can talk about. Now we come back to the beginning of the symposium. Thank you very much for your attention. I hope you enjoyed this presentation. And salvemos el mundo, salvemos la Tierra. Es el único planeta con cerveza. Gracias.